Okay, guys, so we are going to go over the answers for the exit ticket you did last class. So in last class, we learned momentum, and momentum is P equal mv, right? And then we also learned impulse. Impulse has the same unit of momentum, and basically impulse is just the change in momentum. So our another formula is F, force times time, equal mass times delta V, or delta M times V, the same thing. So these are the two formula you have to use. And let's take a look at number 1. So when you do the problem, right, you write a given. You're given M equal 800 kilogram. And then your velocity V is 27.8 meter per second. Very simple. Momentum P equal mv equal 800 kg times 27.8 meter per second. And then you get your answer. Right? And then part B. What velocity is needed for 2400 kilogram car in order to have the same momentum? Okay, so I do need to find the momentum, the first part. So your momentum is 22 to 40 kilogram meter per second. Okay, so we use the same formula, P momentum equal mv. And here, our m is different. M is 2400 kilogram, and our momentum is what we got, 22,240 kilogram meter per second. And you plug in number 22,240 equal 2400 times V, right? Divide by 2400 on both sides. Your V equal 9.27 meter per second. Okay. All right, number 2. Okay. What is the change in momentum? Right? Our given M equal 250 kilogram. And then our time, the force is consistent. And then your time is 60.0 second. The scooter increase. Speed from V initial is 6 meter per second, and V final is 28 meter per second. Okay. Change in momentum. Change in momentum is mass times changing velocity. So it's equal to 50 kilogram times 28, oh, that's a parentheses, times 28 minus 6 meter per second. And you do the calculation. You got 50. Oh my goodness, my pen. You got 5,500 kilogram meter per second. All right, that's part A. Part B, what is the magnitude of the force? So, Ft equal delta P, right? So F equal delta P divided by time. Delta P is what we just got, 5,500, divided by the time, which is 60 seconds, and you get 91.7. And unit is Newton. Okay? All right, number 3. The brake on a 15,680 Newton car exerts stopping force of 604 Newton. The car's velocity changed from 20 meters per second to 0 meters per second. So A, which is straightforward, your mass, okay, Fg equal mg. So m equal Fg divided by gravity. Your Fg, gravitational force, is the weight of the car, 15,680. Keep moving. Newton divided by the gravity is 9.81 meter per second square. All right, so we got 15680 divided by 9.81 equal to 1,598.4 kilogram. Or you put 1598 is fine. Okay, B. What was the initial momentum? Initial momentum initial is mass times initial velocity. So our mass is 1598.4 kilogram. Our initial velocity is 20 meter per second. So your answer is 31,967.4 kilogram times meter per second. Okay. What was the change in momentum for the car? C. The change in momentum, so delta P is mass times delta V, which is 1598.4 kilogram times, okay, it's V final. V final is 0. Subtract V initial. So it's 0 minus 20 meter per second. So it's the same answer as earlier, but it's negative 31,967.4 kilogram times meter per second. Okay, D. How long does it take? So take force times time is equal to delta P. Our force, the stopping force, is 640. So 640 Newton times time is equal to the negative, 31,967.4. Okay, here, the force should be negative. Reason why is because, remember, our force, our momentum, impulse, and everything, velocity, they have the same direction, right? So they're vectors. Vectors has direction. If you go one direction, it's positive, and the other direction is negative. So if we say going forward is positive, okay? Going forward is positive. So the stopping force is pushing the car backwards. Okay? So the force is negative. And the momentum or impulse overall is kind of like frictions going backwards. Right? Momentum or final momentum is stopping it. So it's also negative. Therefore, your answer is positive, which give you 49.9 seconds.